Welcome to B&K Enterprises 2-hour asbestos awareness video. This video is designed to meet OSHA's requirements for General Industry Standards for Asbestos number 1910.1001 and the General Construction Standard for Asbestos 1926.1101. This video contains information on the uses and forms of asbestos, the health effects associated with asbestos, the regulation of asbestos, identification of asbestos-containing materials, and identification of damage, deterioration, and delamination of asbestos-containing materials. In the first portion of our video, we will be discussing the history of asbestos, its forms, its physical characteristics, the health effects associated with asbestos, and the regulation of asbestos-containing materials.
The term asbestos identifies a group of magnesium silicate minerals which have, for thousands of years, been the single most fireproof material known to man. The word asbestos stems from the Greek word quenchable, derived from the observation that the material will not burn. Recorded uses of asbestos date back thousands of years. The first recorded use of asbestos was in Finland about 2500 BC, where the material was used in the mud wattle for wooden huts and as a strengthening material for pottery. Ancient records also indicate that the material was woven into tablecloths and fireproof coverings as well. Large deposits of asbestos have been mined in Canada, South Africa, and Russia for centuries. Asbestos minerals are mined much like any other mineral. The material comes out of the ground in large pieces that must then be manufactured into usable products. There are two broad categories of asbestos materials: serpentines and amphiboles. These terms describe the molecular configuration of the material. In the serpentine group, the molecules are connected in long lines. In the amphibole group, the molecules are interconnected in a bowl shape. Under magnification, the minerals in the serpentine group look like long, wavy bundles of material. Those in the amphibole group look like needles. Chrysotile is the only mineral that is included in the serpentine group. However, 90% of the asbestos on the Earth is chrysotile. The amphiboles include amosite, chrysotolite, tremolite, actinolite, and anthophyllite. Amosite and chrysotolite are the most common amphiboles. Tremolite, actinolite, and anthophyllite are very rare minerals. Unlike man-made fibers, asbestos comes out of the ground as rocks consisting of fiber bundles which continue to split into smaller and smaller bundles. The average fiber diameter ranges from 0.11 to 0.24 micrometers. However, asbestos can split into even smaller bundles which cannot be seen with an optical microscope. This is a picture of asbestos fiber under magnification. These bundles of fiber are so small and so fine that once they become airborne, they settle out of the air very slowly. Each type of asbestos has been found to have different aerodynamic properties and different toxicities. However, there are several physical characteristics that all of the asbestos minerals share. They include heat and chemical resistance, noise insulation, friction resistance. They are brittle, fibrous, and indestructible by common agents. In this demonstration, we will expose a fireproof electrical wire to flame. Notice that the wire is covered with a thick, flexible sheathing. During the burning process, most of the covering is burned away. The fine white fibrous material left is the asbestos lining. Asbestos minerals will not burn. They will, however, glassify at around 2000 degrees Fahrenheit. Chrysotile, the most common of the asbestos minerals, has fine, silky fibers with a high tensile strength. Under magnification, chrysotile appears as wavy bundles of long fibers. Chrysotile is also the most chemically reactive of the asbestos minerals. The rest of the asbestos minerals are amphiboles. They have fine, needle-like shapes under magnification. They are very chemically unreactive. The most common one is amosite. This mineral represents about 1 to 2% of the asbestos minerals in the world. It is very chemically unreactive and does not respond well to wetting agents. It is sometimes called brown asbestos because it has a brown tint. The third most common asbestos mineral is chrysotolite. This is commonly referred to as blue asbestos because of its blue tint. It is the most inert of the asbestos minerals. Asbestos is an excellent material for insulating and fireproofing, and during the Industrial Revolution, its use became widespread. Industrial uses began as early as 1870, when asbestos was used in trains as the insulator for boilers. After 1900, the use spread to ships as insulation for steam pipes and boilers. In the early 1940s, U.S. insulation contained chrysotile from Quebec. During World War II, the use of amosite was widespread in U.S. ships and shipyards. After World War II, the use was expanded to buildings as sprayed-on fireproofing and sprayed-on acoustical surfacing. Between 1950 and 1970, the use of asbestos as insulation, fireproofing, pipe wrap, and so forth was widespread. It is estimated that 75% of all multi-story buildings in the U.S. built during this period have some form of asbestos. At the height of the industry, asbestos was used in over 3,600 commercial and industrial products. Some common commercial uses included papers and felts, floor coverings, asbestos cement products, gaskets, textiles, automotive, appliances, construction products, electrical products, paints, coatings, and sealants.
The older products are primarily low-density insulating materials that were very crumbly and usually made of the amphibole type fibers. The new products are made entirely of chrysotile fibers and are always encapsulated in some kind of resin or cement. Typical examples would be cement piping, gaskets, or brake pads. It's indeed unfortunate that the very characteristics that make asbestos the wonderful insulating and fireproofing material that it is are the very same characteristics that make asbestos the health hazard that it is to anyone who is exposed to it.
Asbestos-related diseases involve the inhalation of asbestos fibers and subsequent damage to the lungs and the lining around the lungs. The main function of the lungs is rapid gas exchange. This is accomplished by a well-coordinated interaction of the lungs with the central nervous system, the diaphragm and chest wall musculature, and the circulatory system. The functional structure of the lung can be divided into two parts. One, the conducting airways, or the respiratory tree, and two, the gas exchange portions, or the alveoli. The conducting airways start at the nose and include the trachea and the bronchial tubes. The respiratory tree divides into paired branches of unequal length and diameter. The diameter of a branch is related to the number of alveoli at the end of that branch. The respiratory tree is lined with hair-like structures called cilia that filter the air as it passes into the lungs. After the material is trapped, the cilia help move the material back up the bronchial tubes into the back of the throat, where it is either spit out or swallowed. Gas exchange occurs in the alveolus, where the blood flow and inspired air are separated only by a thin tissue layer. Gas exchange takes 0.25 seconds. The entire blood volume of the body passes through the lungs each minute in the resting state. That is 5 liters per minute. The total surface area of the lungs is about 80 meters square, equivalent to the size of a tennis court. Anatomically, most of the alveolar wall is comprised of the capillary. Gases are exchanged between this channel of blood and the alveolar spaces. The entire surface of the alveolus is covered by epithelial cells. The alveolar wall also contains other cells such as fibroblasts, macrophages, and lymphoid cells. Alveolar macrophages constitute a small percentage of the cells in alveoli, but they represent the main cellular host defense mechanism in the alveolar space. When a person is exposed to asbestos fiber, the cilia in the walls of the bronchial tubes trap most of it. However, some of the fiber is so small that it makes its way into the alveoli and embeds itself into the lung tissue, where it will remain for a long time. When asbestos becomes lodged in the alveoli, macrophages identify the material as an intruder and attempt to destroy it. However, asbestos is so unreactive that the macrophage is unable to destroy it. So the macrophage develops a protective coating around the fiber to protect the body from the fiber. The protective coating is called a cyst, and as more and more cysts are made, lung area is reduced and breathing becomes less efficient. Diseases develop as a result of this process.
Asbestos-related diseases have been known for thousands of years. In the 1st century A.D., the Greek philosopher Strabo and the Roman naturalist Pliny the Younger both wrote of sicknesses that they observed in the slaves who worked in asbestos mines. It's only been recently, however, that we've better understood the disease and its causes.
In the early 1900s, doctors in Britain established a presumptive connection between an asbestos worker's death and his occupation. As early as 1917, doctors at the University of Pennsylvania School of Medicine observed lung scarring in X-rays of asbestos factory workers. In the late 1920s, British doctors conducted a study which showed evidence of pulmonary fibrosis in more than 25% of the workers involved in the asbestos textile industry. As a result of this study, the British Parliament passed legislation which required better exhaust ventilation and dust suppression in asbestos textile factories. The relationship between lung cancer and asbestos was established in 1949, when a report was published in which an excess number of lung cancer cases among asbestosis victims was described. Mesothelioma was first recognized as an asbestos disease in 1960, when a series of cases in South Africa were publicized.
Today we know that there are 3 diseases associated with asbestos exposure. Those diseases include asbestosis, lung cancer, and mesothelioma. All 3 diseases are characterized by a very long latency period, which means that it takes 20 to 40 years for the first symptoms of the disease to show up.
Given the poor work conditions of the past, the widespread use of amphiboles up until the 70s, and this long latency period, it is not surprising that new cases of asbestos-related disease continue to be observed. Workers in the shipbuilding and construction industries who installed friable asbestos insulation materials have been the most severely affected. Many of these workers were exposed to dust levels 100 to 200 times those permitted by current OSHA standards. The first asbestos-related disease is asbestosis. Asbestosis, or pulmonary fibrosis, is a chronic disease in which the lungs become scarred as a result of a biological reaction to asbestos fibers becoming lodged in the lung tissue. There is no effective treatment for asbestosis. The disease is usually disabling or fatal. The risk of asbestosis is minimal for those who do not work with asbestos. The disease is rarely caused by neighborhood or family exposure. Those who renovate or demolish buildings that contain asbestos may be at significant risk, depending on the nature of the exposure and the precautions taken. There is a direct dose-response relationship to this disease. The disease results after exposure to high concentrations of fibers over a long period of time, measured in years. Symptoms include shortness of breath and a dry cough. As the disease progresses, victims develop a bluish or purplish coloration of the mucous membranes and skin due to lack of oxygen to the blood. The disease results in reduced lung function and therefore a greater demand on the heart. The victims usually die from heart failure, not from the disease itself. The disease is preventable with proper equipment and work practices. The second asbestos-related disease is lung cancer. Lung cancer is now responsible for half of the deaths associated with asbestos exposure. The incidence of lung cancer in people who are directly involved in the mining, milling, manufacturing, and use of asbestos and its products is much higher than in the general population. The cancer results in a tumor which usually begins in the lower lobes of the lung. The tumor invades other tissues and can spread. Generally, the earliest symptom is the development of a persistent cough. Later symptoms include loss of appetite, weight loss, pain, and weakness. The combination of asbestos exposure and smoking greatly increases the risk of developing lung cancer. Smoking, in combination with asbestos exposure, doesn't just double the risk. The combination has a synergistic effect in which the risk is multiplied many times. Asbestos workers are 5 times more likely to develop lung cancer than the general population. Smokers are 10 times more likely to develop lung cancer than the general population. A 1-pack-a-day smoker exposed to asbestos has an increased risk of approximately 50 times that of a non-smoker. A 2-pack-a-day smoker exposed to asbestos has an increased risk of approximately 90 times that of a non-smoker. The third asbestos-related disease is mesothelioma. Mesothelioma is a rare form of cancer which most often occurs in the thin membrane lining of the lungs, chest, abdomen, and rarely heart. About 200 cases are diagnosed each year in the United States. Virtually all cases of mesothelioma are linked with asbestos exposure. Approximately 2% of all miners and textile workers who work with asbestos, and 10% of all workers who were involved in the manufacture of asbestos-containing gas masks contract mesothelioma. People who work in asbestos mines, asbestos mills and factories, and shipyards that use asbestos, as well as people who manufacture and install asbestos insulation, have an increased risk of mesothelioma. So do people who live with asbestos workers, near asbestos mining areas, near asbestos product factories, or near shipyards where use of asbestos has produced large quantities of airborne asbestos fibers. Symptoms include shortness of breath, chest pain, and weight loss. The disease is always rapidly fatal, usually within a year after diagnosis. There is no known relationship between smoking and the risk of developing mesothelioma. 3 things seem to determine your likelihood of developing one of these asbestos-related diseases. 1. The amount and duration of exposure. The more you're exposed to asbestos and the more fibers that enter your body, the more likely you are to develop asbestos-related problems. 2. Whether or not you smoke. If you smoke and you've been exposed to asbestos, you're far more likely to develop lung cancer than someone who does not smoke. Organizations that may offer programs, support, or information to help people stop smoking are the National Cancer Institute at 1-800-4-CANCER and the American Heart Association at 1-800-242-8721. The third thing that seems to determine the likelihood of developing an asbestos disease is age. Cases of mesothelioma have occurred in the children of asbestos workers whose only exposures were from the dust brought home on the clothing of family members who worked with asbestos. The younger people are when they inhale asbestos, the more likely they are to develop mesothelioma.
This is why enormous efforts are being made to reduce and minimize the exposure of asbestos to children in schools. As the exposure to asbestos continues, the body burden of asbestos increases as fibers collect in the lungs. It's very important to reduce and minimize your exposure. As exposure increases, the risk of disease increases as well.
The Environmental Protection Agency banned the use of spray-applied asbestos fireproofing materials in 1973. It further broadened this ban in 1978. The EPA issued a NESHAPS asbestos standard for renovation and demolition of industrial and commercial buildings. Also during this time, OSHA developed two regulations for asbestos exposure: a general industry standard, 29 CFR 1910.1001, and a construction standard, 29 CFR 1926.1101. These two regulations describe the permissible exposure limits to asbestos, proper work practices, and training requirements for all persons who may be working with or around asbestos-containing materials. A copy of each of these standards is included in your course packet. Permissible exposure levels, or PELs, are stated as 8-hour time-weighted averages, and over the years have been lowered from a permissible exposure level of 10 fibers per cubic centimeter to the current standard of 0.1 fibers per cubic centimeter.
We've concluded the first half of our Asbestos Awareness program. At this time, your instructor will hand out a worksheet that will help you review the material that we've just discussed. Please stop the videotape and take 15 to 20 minutes to fill out the worksheet.
We will now continue our program by reviewing the worksheet. Number 1. Asbestos is known for the fact that it is A. Fireproof, B. A good insulator, C. Resistant to friction, or D. All of the above. The correct answer is D. All of the above. Number 2. Asbestos has been used as a fireproof material for how many years? A. 200, B. 4,000, C. 3,000, or D. 1,000. The correct answer is B. 4,000 years. Number 3. 90% of all the asbestos known on the face of the earth is what type? A. Amosite, B. Gracitolite, C. Tremolite, D. Chrysotile. The correct answer is D. Chrysotile. Number 4. Which of the following asbestos minerals are heat, chemical, noise, and friction resistant? A. Amosite, B. Chrysotile, C. Tremolite, or D. All of the above. The correct answer is D. All of the above. Number 5. Asbestos use first became widespread during A. the French Revolution, B. the Revolutionary War, C. the Industrial Revolution, or D. none of the above. The correct answer is C. the Industrial Revolution. Number 6. Which of the following products contained some asbestos at the height of its use prior to 1978? A. Hair dryers, B. Cigarettes, C. Gloves, D. All of the above. The correct answer is D. All of the above. Number 7. Asbestos-related diseases occur when persons are exposed to asbestos. The main route of exposure is A. Inhalation, B. Skin contact, C. Ingestion, or D. All of the above. The correct answer is A. Inhalation. Number 8. Diseases associated with asbestos occur in the A. Brain, B. Lung, C. Heart, or D. Liver. The correct answer is B. The lung. Number 9. Diseases associated with asbestos occur because A. Fibers become airborne, B. Fibers get trapped in the alveoli. C. Materials containing asbestos get disturbed. Or D. All of the above. The correct answer is D. All of the above. Number 10. The 3 diseases related to exposure to asbestos-containing materials are asbestosis, lung cancer, and mesothelioma. The correct answer is A. True. Number 11. All asbestos-related diseases have a long latency period, which means that it takes 20 to 40 years for the first symptoms to show. The correct answer is A. True. Number 12. The combination of asbestos exposure and smoking greatly reduces the risk of developing lung cancer. The correct answer is B. False. Number 13. The amount and duration of exposure, whether or not you smoke, and your age all seem to determine your likelihood of developing one of these asbestos-related diseases. The correct answer is A. True. Number 14. OSHA stands for the Occupational Safety and Health Administration. The correct answer is A. True. Number 15. OSHA standards do not specify proper work practices for dealing with asbestos materials. The correct answer is B. False. Number 16. OSHA standards have specified training requirements for all persons working with or around asbestos materials. The correct answer is A. True. Number 17. OSHA standards specify that the 8-hour time-weighted average permissible exposure level for asbestos is A. 1.00 fibers per cubic centimeter, B. 0.001 fibers per cubic centimeter, C. 0.02 fibers per cubic centimeter, or D. 0.10 fibers per cubic centimeter. The correct answer is D. 0.10 fibers per cubic centimeter. Number 18. Proper work practices make the risks of working with asbestos very low. The correct answer is A. True. Number 19. Persons most at risk of contracting an asbestos-related disease today are A. Housekeeping personnel, B. Asbestos removal workers, C. Maintenance personnel, or D. All of the above. The correct answer is B. Asbestos removal workers. Number 20. Asbestos poses a health hazard when asbestos fibers get into the air and people breathe them into their lungs. Asbestos-containing materials release fibers into the air whenever they are A. Pulverized, B. Sanded, C. Drilled, or D. Any of the above. The correct answer is D. Any of the above. Please stop the video and take a short break.
Welcome to the second portion of our Asbestos Awareness program. In the first segment, we looked at asbestos, its history, its health effects, and its regulation. Let's turn our attention now to identifying asbestos on building systems, taking a look at when it's hazardous and some proper work practices.
The most common way for asbestos fibers to enter the body is through breathing. In fact, asbestos-containing material is not generally considered to be harmful unless it is releasing dust or fibers into the air where they can be inhaled or ingested. Asbestos building materials can be broken into 2 broad types, those that are friable and those that are non-friable. Asbestos is most hazardous when it is friable. The term friable means that the asbestos is easily crumbled by hand, releasing fibers into the air. However, even friable materials are not necessarily hazardous if they're managed properly. For example, sprayed-on asbestos insulation is highly friable. Asbestos floor tile is non-friable. Neither of these materials is friable at the present time. However, any vibration or handling of the sprayed-on material will make it immediately friable. The floor tile, on the other hand, will not become friable without some effort, such as sanding, grinding, or pulverizing. Handling floor tile does not make it friable. Other building systems that may have asbestos in them include ceiling tiles, floor tiles, laboratory cabinet tops, shingles, fire doors, siding shingles, drywall, and hard plaster. While some of these materials are considered friable, they are all examples of materials that will not release asbestos fibers unless they're disturbed or damaged in some way. If an asbestos ceiling tile is drilled or broken, for example, it may release fibers into the air. If it is left alone and not disturbed, it will not. Asbestos pipe and boiler insulation does not present a hazard unless the protective canvas covering is cut or damaged in such a way that the asbestos underneath is actually exposed to the air. Damage and deterioration will increase the friability of asbestos-containing materials. Here is a picture of damaged pipe insulation. Water, vibration, and maintenance activities are probably all partial causes of the damage to these materials. The damage has exposed asbestos-containing materials to the air. These materials are all friable, and if they're crumbled or damaged in any way, they will release fiber into the air. One of the most common types of damage to building materials is water damage. Leaks in roofs or pipes or floods from plugged drains are all common problems. When water gets into asbestos-containing materials, it may break down the compounds that hold the material together, causing it to be more friable than it was before it got wet. It may also completely destroy the matrix of the material, leaving asbestos exposed, or on the floor, or in the water that damaged the material. Once the asbestos is released from its adhesive materials, it is able to become airborne. Here is a damaged floor tile. Notice that the tiles are no longer sticking to the floor, and some of them are broken. This damage has occurred because of water and physical abuse. The material has broken into several pieces. While the breakage is severe and the water has loosened the tiles from the floor, the matrix that the asbestos is in is not damaged, and therefore the material is still not friable. Continual vibration is another source of damage to asbestos products. This is particularly common on pipes connected to fans and pumps. The vibration in effect crumbles the material over a period of time. As long as the material is sealed in a wrap or enclosure, the asbestos cannot be released. Another source of damage is aging. All materials become more brittle as they get older. Floor tiles, pipe insulation, and other insulation materials all suffer from the effects of aging. As materials get older, they're more prone to damage from any source, thus releasing fibers into the air. Physical impact such as drilling, grinding, buffing, cutting, sawing, or striking can break down the materials, also making fiber release more likely. OSHA requires that buildings that have asbestos-containing materials in them will have notices posted stating that the building contains asbestos. OSHA also requires that the materials that contain asbestos be labeled. OSHA further requires that materials that have not been tested or were applied before 1980 be labeled and assumed to be asbestos until it is proven that they are not asbestos. No one can tell whether a material has asbestos in it just by looking at it. Building materials must be tested. In most states, there are licensing and training requirements for persons who do building inspections for asbestos. During an inspection, the inspector will identify all the materials in the building that may be suspect. He will then collect samples of them and send them to a laboratory for analysis. Once the results are in, The inspector will then issue a report to the building owner, informing him what materials had asbestos in them. It is then up to the owner to decide what to do with them. OSHA requires that they be labeled. The owner may also elect to have them removed or encapsulated.
At this time, your instructor will present to you where asbestos is located in your facility and who to contact when you have questions concerning asbestos. Please stop the tape until you have completed reviewing this information. Now that you're familiar with where asbestos is in your facility, let's talk about how to avoid exposure.
If you do not know whether something is asbestos or not, assume that it is until proven otherwise. Remember, in order to avoid being exposed to asbestos, you must be aware of the locations. Remember, you cannot tell if floor or ceiling tiles contain asbestos just by looking at them. If you have questions about whether or not a material is asbestos, never try to take a sample yourself unless you're licensed to do so. Contact the people in charge of the asbestos program in your facility. If you have reason to suspect that something is asbestos, do not disturb it. Never drill, hammer, cut, saw, break, damage, move, or disturb any asbestos-containing materials or suspected materials. Housekeeping and custodial care. Housekeepers and custodians should never sand or dry buff asbestos-containing floor tiles, and only wet stripping methods may be used during stripping operations. Low abrasion pads should be used at speeds below 300 RPM. Broken or fallen ceiling tiles should be left in place until identified. Only after they've been identified as safe may they be removed. Asbestos tiles will be removed by asbestos abatement workers. Broken or damaged asbestos floor tiles must also be removed by asbestos abatement workers. Report any suspect broken tiles to the people in your facility in charge of your asbestos program. Spills. It is important to report any damaged asbestos-containing materials to the people in charge of your asbestos program immediately. If, for example, you discover that some asbestos pipe insulation has been knocked off a pipe, this would be considered a spill. As such, it would need to be cleaned up immediately by asbestos abatement workers. Do not attempt to clean up spills yourself. Disturb the material as little as possible. Also, report any damaged pipe insulation, ceiling tile, 9-inch floor tile, fallen clumps of sprayed-on insulation, etc. Take measures to prevent others from disturbing the spill until the asbestos abatement crew arrives.
By knowing where asbestos is located in your facility and taking measures not to disturb it, you will protect yourself and others from this hazardous material. At this time, your instructor will hand out worksheet number 2 to help you review the material that we have just discussed. Please take 15 or 20 minutes to complete this worksheet.
We will now continue our program by reviewing worksheet number 2. Question number 1. Most older buildings will contain some asbestos. List 3 places it is likely to be found. Correct answers include floors, ceilings, walls, boiler rooms, fan rooms, maintenance areas, behind walls, and above suspended ceilings. Number 2. If you suspect that a material contains asbestos, you should never A. Sand it, B. Cut it, C. Drill through it, D, any of the above. The correct answer is D, any of the above. Number 3. Asbestos fibers are so small that they may stay suspended in the air for hours or even days. The correct answer is A, true. Number 4. Which source of asbestos is the most friable? A, sprayed-on insulation. B, undamaged ceiling tiles. C, floor tiles. Or D, plaster wall. The correct answer is A, sprayed-on insulation. Number 5. Asbestos-containing ceiling tiles, floor tiles, shingles, and siding will not release asbestos fibers unless disturbed or damaged in some way. The correct answer is A, true. Number 6. If you accidentally knock off a chunk of sprayed-on asbestos insulation, you should A, carefully sweep it into a Ziploc bag. B, leave it for a custodian to clean up. C, report it immediately. Or D, get a vacuum. The correct answer is C, report it immediately. Number 7. Asbestos-containing floor tiles may become friable and release asbestos fibers into the air if they are A, sanded, B, drilled, C, dry buffed, D, any of the above. The correct answer is D, any of the above. Number 8. Wet stripping methods for rewaxing asbestos floor tiles include the use of low abrasion pads and buffers operated at speeds below 300 RPM. The correct answer is A, true. Number 9. What is the name and office phone number of the contact person responsible for asbestos-related concerns at your facility? Number 10. Asbestos-containing materials are required by law to be labeled. The correct answer is A, true. Number 11. Non-asbestos-containing materials that have not been tested are supposed to be labeled as suspect asbestos-containing materials. The correct answer is A, true. Number 12. You can tell if a material is asbestos if you A, look at it and see if it has white fibers in it. B, smell it. C, pulverize it and check for fibers. Or D, none of the above. The correct answer is D, none of the above. Number 13. If you find a piece of pipe insulation on the floor in a mechanical room, you should A, pick it up and throw it away. B, leave it alone and check to see if it is asbestos before doing anything with it. C, ignore it and go on with your work. D, none of the above. The correct answer is B, leave it alone and check to see if it is asbestos before doing anything with it. Number 14. Damaged asbestos-containing materials, A, may pose a health risk to persons working in the area. B, should be reported. C, should be repaired. Or D, all of the above. The correct answer is D, all of the above. Number 15. Housekeeping and maintenance personnel are supposed to repair damaged asbestos-containing materials. The correct answer is B, false. Number 16. Asbestos pipe and boiler insulation does not present a hazard unless the protective canvas covering is cut or damaged in such a way that the asbestos underneath is actually exposed to the air. The correct answer is A, true. Number 17. Damage and deterioration will increase the friability of asbestos-containing materials. The correct answer is A, true. Number 18. Asbestos is most hazardous when it is friable. The correct answer is A, true. Number 19. The term friable means A, hard, B, soft, C, easily crumbled by hand, or D, none of the above. The correct answer is C, easily crumbled by hand. Number 20. List 3 ways in which asbestos-containing materials can be damaged. Some examples are aging, water, vibration, and physical damage.
This concludes our 2-hour asbestos awareness program. Thank you for joining us, and we hope that you have learned how to work safely around asbestos-containing materials.